All right, line A5, learning task 4. This is the fourth video that we have, and this one we are going to go and do a delta to Y type of calculation. And because we've got two different types of configurations, we're going to have to keep all of our individual formulas straight. Let's do that right now just by going and placing them real quickly down on their side of the equation over here. I know that on this side, my delta, I know that my E line is equal to my E phase. And I know that my I line is equal to my I phase times root 3. Over on the other side of the equation over here, I know that my E line is equal to my E phase times root 3, as well as I know that my I line is equal to my I phase over here on the far side. So we're going to go and use each of those individual formulas overall on either side. And then for both of them, we know that VA is equal to my E line times my I line times root 3. And we know that my watts is equal to my VA multiplied by my power factor. That's going to be true for both sides. Once we have the line values of voltage, which is going to be in between those two, we can do absolutely everything else that we need to across the middle over there. Same format as what we did before. We are going to go and start at our source. We're going to figure out our values of voltage. Once we know our values of voltage, we take them to our load. We figure out our values of current. Once we know our values of current, we can then go and figure out our VA and our power that we are going to go and have. Let's start by identifying what we do know. Once again, 120 volts that we have for each of my phase values of voltage and resistances of 10 ohms that I'm going to have for each of my phase values of resistance. Because it is actual resistances as well, pure ohmic resistance, we know that I'm going to go and have a 1.00 power factor as well. Okay, let's start on our first side. We know that we have got my my E line is equal to my E phase. We can go and substitute in there. If I'm looking for E line is equal to my E phase, I can take that 120 volts up. Therefore, I'm going to go and have a E line of 120 volts on my line over here. We're going to take that 120 volts down to the other side over here. And at the other side, we see that we have got a line-to-line value of voltage over here, but we see that we're going to need to go and get a phase value of voltage for these as well, because we're going to be dropping in a distinct amount of volts over top of this first resistance and then over top of the next ones that we have here. Well, those are going to be calculated. If we're going to look for our phase value of voltage, we can take this formula and we can go and rework it. E phase is going to be equal to my E line divided by root 3. Now that we have got that laid out, we can just substitute in values as we see them. So we see that we've got a line value of voltage of 120 volts. So we are going to go and place in 120 over here. And that is going to go and give me my phase value of voltage. Let's punch that into our calculator over here. 120 divided by root 3. Which gives me a value of 69.28 volts that we are going to go and have over here. So my phase value of voltage is going to be 69 volts that I'm going to go and have over here. Perfect. Now that we have got a phase value of voltage, we can calculate one more phase value, and that last phase value we're going to be looking for is going to be my I phase. We're going to do that by using all phase values. Always has to keep it inside of the phase. So E phase divided by my R phase. And we have got each of those values. E phase is going to be 69. And my R phase is going to go and be 10 ohms. So my current is going to be 69 divided by 10, which means that my phase value of current, I phase, is going to be equal to 6.9 amperes over here. Perfect. Now that we've got that 6.9 amperes, On our phase value of current, we also know that my phase value of current and my line value of current are the same because there's only one path for that current out of here onto that line. So therefore, my line current is going to be the same 6.9 amps that we are going to have. We can now go and redo this formula down here with actual numbers. We've got a line value of voltage, 120 volts. We've got a line value of current. Sorry, I'm going to go and have 6.9 amps over here. Line value of current over here. We can multiply those together. 120 times 6.9 times root 3. 120 times 6.9 times root 3 equals a value of 1,434. My VA for this system over here, 1,434 VA. And because I've got a unity power factor, I'm going to go and take that VA multiplied by 1.0, and I'm going to find out that I have got watts of 1,434 watts that I'm going to go and have over here. The very last thing that we have to go and calculate off of this one is we've got one last value that we don't see on here, and that is going to be my value of I phase on my alternator itself. We know that we are delivering 6.9 amps on the line, but we don't know what's going to be inside of the actual phase value over here. And to do that, we're going to rework this formula over here so that it says I phase is equal to my I line divided by root 3 over here. Let's go and put values into this thing. I line is going to go and be a value of 120. My, root 3 over here is going to go and, what am I doing with I phase 120? That's my E phase. No wonder this isn't making sense. I phase over here, and I line is what we're looking at. I line is 6.9 amps divided by root 3 is going to give me my phase value. I'm sorry, guys. Sometimes you lose track of where you are. 6.9 divided by second root 3 equals a value of 3.98, or what we could effectively say is going to go and be a value of 4 amps. I phase over here is going to be equal to 4 amps. Perfect. That is the very last of these 4 calculations that we had to go and get through. These calculations, all of these calculations that are out of Learning Task 4 are all based around this being balanced systems. And by balanced system, they mean that all of my load resistances are equivalent. So I'm going to have the equal amount of current inside of each line. As soon as we have unbalanced loads, we're going to have to go and do different calculations, individual, one at a time ones, until we can figure out what each of my individual amounts of power is going to be, and then we would just have to add them all up past that. Thankfully, though, these are the easy, cheesy calculations that we're still covering in these. So we've done the simple ones. We will get to the more complicated ones a little bit later on.